Hello, I'm Tom Nahumi from Dell EMC, and today I'm going to show you a demonstration of snapshotting and restoring MS SQL Docker container with Kubernetes and Dell EMC XtremIO Container Storage Interface plugin. In a multi-tenant containerized application and DevOps environments, all volumes are virtually provisioned at container granularity. Operations such as snapshots, compression, and others are not at a cluster or storage-wide property, but rather per container. As you can see, I installed the XtremIO CSI plugin on a 3-node Kubernetes cluster, while the nodes are running the worker role, and one of them is also running the controller role. Under Storage Classes tab, we can find the predefined XtremIO storage classes, the default one, as well as the high, medium, and low storage classes, which are based on XtremIO quality of service policies and configured to consume storage from the XtremIO cluster. For the purpose of this demo, I'm using a single brick, and as you can see, there are no LANs provisioned yet. Now, let's connect to the Kubernetes master node CLI and work through the creation of an MS SQL stateful set inside the Kubernetes cluster. As you can see on the screen, I'm creating an 8 GB persistent volume claim with the name MS SQL data, which is going to be the persistent volume for my MS SQL instance. As you can see, the volume has been created at the array level, as well as the CSI provisioner sidecar sent a request to the XtremIO XMS via REST API to create my volume. The next step is creating our MS SQL 2017 stateful set. As you can see, there are lots of parameters here, but I want to focus on the persistent volume claim, which I created earlier, and this will be attached to this Kubernetes pod as a persistent volume during the pod deployment. In the background, we can see that the volume is being mapped to the relevant Kubernetes node, formatted with a file system, and now it's ready and connected to our pod. By running the kubectl get pods, we can see that our pod is up and running. So let's connect to it, create a test database, and fill it with some data. Here, I'm creating a sample database called testdb, creating a table called inventory, and inserting some values into it. Now that we have our database running, let's move to the snapshot part. As part of the Dell EMC XtremIO CSI plugin installation, a volume snapshot class is created with the name CSI XtremIO XVC, which stands for XtremIO Virtual Copies, and the snapshotter is set to the XtremIO CSI plugin. Also, I created a volume snapshot YAML file and set the source of this file as the persistent volume I created earlier, which refers to the persistent volume which is connected to the MS SQL database. As you can see, the new Kubernetes snapshot object is being created, as well as the XtremIO snapshot of the original volume. On the XMS, we can see that a new read-only snapshot and a new snapshot sets were created. Now, let's delete the existing MS SQL stateful set and its PVC and restore the data from a snapshot. I created in advance another PVC YAML file and set the storage class to XtremIO CSI plugin, and the source of the snapshot volume I created previously. Now, I'm running the kubectl command to create this PVC, and the new volume is being created from the snapshot and it's ready to use. As we can see, the old volume is no longer exist, and a new volume is being created from that snapshot I took earlier. With that, let's move on. I'm deploying the same MS SQL stateful set, but now with a minor change. I set the PVC to the new volume I just created from the snapshot, and now I'm running the kubectl create command to create it. As you can see, the MS SQL database is up and running and connected to the new persistent volume I've just restored. Let's connect to the database and run a query to verify that the data is still there. I'm connecting to the test database and running a select query to present the table data. As you can see, I managed to restore my data using the unique capability of the XtremIO CSI plugin and Kubernetes snapshots. The integration between Dell EMC XtremIO X2 and Kubernetes using the CSI plugin allows the customer to rapidly deploy and scale stateful applications and containers by leveraging XtremIO's virtual copy technologies, which abstracts the copy operation as a unique in-memory metadata operation with no backend media impact. XVC enables instantaneous high-performance copy of any dataset in almost any quantity desired. It is entirely space efficient with data services such as inline deduplication and compression, and does not impact production or other copies. I hope you will find this demo useful, and thank you very much for watching.